So this is a review of the solutions to the assessment 2. This problem set is heavily built on top of assessment 1, so make sure that you have a strong foundation of asynchronous programming before attempting it. And as always, I urge all students to at least attempt each of these problems before looking at the solutions, as they're much more valuable if you know specifically why you got stuck versus just going straight to the solutions. So the first problem is the synchronization of stocks problem, and there's a major hint right away that it says that this is a review on callbacks. Okay, so we aren't even, this problem specifically isn't really asking you to do observer pattern yet. It's more of a review of, do you understand callbacks? And it's going to be important because callbacks are heavily used inside of this observer pattern. So the question says, starting with the stock portfolio simulator example. And so we have that over here. So in fact, if we run this, okay, this is our stock portfolio simulator example. Every day, whoops, there you go. Every day, every 2,400 milliseconds, about two and a half seconds, the day changes, and with day changing, the stock price will move up or down randomly. Okay, so starting this with this as our base, we're going to edit index.js, replacing the multiple calls to console.log with a single call to console.table. As console.table requires a tabular dataset, the data must be condensed into a single array. Use synchronization techniques. So this is key over here. It says use synchronization techniques in assignment 1 to only print the table after all new day events have come in. What columns you choose to print does not matter. In my example, I choose the simplest choice of printing out all the columns of the immediate object. Do not worry about the formatting of individual data types. Okay, so essentially when it says the columns that you print out doesn't matter, the columns that I choose to print out in this case, well, these are the columns that the object emitted: ticker, name, price, previous change. And I emit those specific columns. So here, ticker, name, price, previous change. And then we have this additional index, which you get automatically when you use console.table. Okay, so the specific values. So what I can just do later on is just do a console.table of this object. Okay, so first let's look at the console.table function to just make sure that you understand how it works. So if I have a tabular data set like stocks.json, so let's look at stocks.json. So stocks.json is this is the same from the previous lecture. Okay, it's an array of objects, and whenever you have this tabular data set, which is typically an array of objects or an array of arrays, you can use console.table to sort of group together common properties. So all the tickers can be grouped together and all the names can be grouped together. If something doesn't have a particular property, sometimes like volatility and growth, they don't appear, then those will be empty cells inside of our table. So what I'm going to do over here, in fact, right, this is the one I want. Let's close that. Is just do console.table on this file. So stocks.js gets imported over here, and then we call it its portfolio data. So I'm just going to very quickly call print the portfolio data. Okay, so this is what console.table does. Okay, so it prints out a table of this data. And so what I want is, I want this table printed out, almost the same. It's got different columns, so I want, instead of ticker and name should be there, price should be there. I'm missing previous and change. Okay, so over here I have volatility and growth instead. Okay, so in order to get previous and change, those are extracted out from inside of here, inside of the new day event. Every time we get a new date, we get the previous price and we get the change. And if you also look at the sample picture, you can see that on each day that it changes, the price changes. So I need to make this dynamic. This is just printing out the table. But every day the price changes, so I want to have that price updating. Okay, so in order to have the price updating, I need to have the stock's new day event, because every time we have a new day in the stock, that stock is going to give us the new price. And over here, I can't do console.table on this object over here because it's just a single row of a table. It's not an entire table. It's just a single row. Let's see. There it is. Okay, so this is just a single row of the table. Okay, so I need to have an array of these objects. Okay, so I'm going to create an array of these objects. What am I supposed to call it? I'll call it daily stocks. Okay, so I'll start off with an empty array. And then on each new day event that occurs, so if you remember from the lecture, we know that if I have 9 stocks inside of here, I'm going to get 9 new day events. Okay, so 9 of these new day events are going to occur. And each one is going to be associated with a specific ticker. So it'll say that the current price of the stock Apple is $500, and the previous price was $490, and the change is 10. Okay, so I'm going to get 9 of these, or 1 of these for each stock that I have inside of stocks.json. And they're going to be associated with their own index in this case. So if I do a console.table inside of here directly, then this is going to print 9 times, which I don't want. Okay, so instead we're going to use our synchronization techniques, and we've only covered one synchronization technique, which inside of your assessment 1 was actually very trivial. It's just a counter. So most synchronization techniques is just using some type of counter. Okay, so essentially what we're going to do, we have this index variable over here, so we can particularly use it if we need to, but let's see if we can avoid using it. So right now, what this code is doing is it's moving our cursor to a specific line, it's erasing that line, and then it's printing out the stock information. Okay, so I'm going to replace this code. That will print out a single console.table. So I should only have console.table executing once. But I need it to be executing inside of here because I need it to be executing when a new day event occurs. Okay, so essentially what I can do is, the trick to this problem is that you're going to use an if statement. So when Google signals its new price, okay, so when Google signals its new price, you're not going to do anything. When Apple signals its new price, you're not going to do anything. But when the very last stock signals its price, okay, that means that you've got all the prices from previously. Okay, when the very last stock of the day signals their price, in this case, the 9th stock signals their price, then you know that you've received all the new day events that you're going to receive, and then you can do console.table. Okay, so I'm going to say daily stocks dot push. So we have an empty array, and we're just going to push in this record. Okay, and in fact, I can probably simplify this to just be stock data, just because I'm operating on it as a whole. No, I'm no longer operating on specific properties of it. So if I don't need to do a destructuring, then I can just call it stock data. But you can do it either way. This is probably prettier if you need to go back and change specific things. Okay. So I'm going to push this into an array. And then I'm going to conditionally call console.table, but only if I know I've reached the last new day event of the day. Okay, so let's see. So how many stocks do I have? I have portfolio.length number of stocks. And if that matches daily stocks.length, and we'll use greater than equals just in case. Okay, so I believe the code has it run such that the Google stock will emit, and the Apple stock will emit, and then the Amazon stock will emit, and so on. But I'm coding this up as if I don't know the order that they emit in. Okay, so all I'm doing is every time I get a new stock, I'm going to push it into this daily stocks array, and then once everything has been received, okay, then I'll use console.table to print out daily stocks. And I need to do a bit of cleanup as well. I need to empty this array afterwards. That way, when the next new day event comes in, okay, that will actually represent the next trading day, that I start again from 0. Okay. And then over here, this gives me a bit of a hint that I need to use console.clear. Okay, so when a new day occurs, I need to erase all the previous day's stuff. Okay, so I'll do that over here. Erase the previous day stuff, then print out the new days table, and then finally move the cursor see. Clear the console, move the cursor to the very top of the page, print out the table, reset the array. Okay, so let's run this. Okay, and so we have it. We have all the stocks that are changing each day. Okay, over here we see the month, day, day as well. So we actually have one additional column over here, which I don't like that much. So I can get rid of pretty easily. But by choosing which columns that I want over here. So if I want to match this exactly, then I want ticker, name, price, previous, change. Ticker, name, price, previous, and change. And then instead of using stock data over here, I can just output that same exact one. Okay, so that will drop that month, day, day column. And so again, I'm pretty sure I'm guaranteed that the order of these will be as is, but I think if you want to be more explicit about that, instead of using .push, you can use square brace index is equal to this object. And then I think the indexes will start at 1 instead. Although this might affect the length, so this might be off by a little bit if we do it this way. Let me double check. Okay, so all right, it does. That's fine. All right, so this is a bit more explicit about where you want the stocks to come in. So just in case you have you change the underlying code of stocks.json, it will preserve the order no matter what. So this one I think is slightly better because it doesn't rest on the assumption that these stocks always emit back in order. Okay, so over here instead we reserve a specific index for the stock. So even if the emits come in at different times, if something's delayed or something, then they still go into their correct spot and you won't have any stocks jumping around. Again, the original one probably doesn't have that type of factor in just because of how the code is written. But if, let's say, the internals were changed, then it might. Okay, so we'll move on to the next problem. The next example has us actually writing our first emitter. We are given a large JSON file composed of multiple quotes, separated by commas, one on each line. So it looks like there's roughly 20 quotes. And it asks us to use day emitter to create two files, module/quote emitter.js. And the constructor accepts a day emitter object. It listens for a new day event and emits a QOTD event that includes a random quote as its second argument. Okay, so the closest example to look at would be the birthday emitter. Essentially, birthday emitter accepts a day emitter object, and it adds its own functionality on top. The difference here is that birthday emitter only conditionally emitted its own birthday event, whereas for the quote emitter, it looks like it emits it every day. So every time it receives a new day event, it emits a random quote as its second argument. Index.js will print a calendar on each new day event, and a quote on each QOTD event. Use console.clear to clear the console between days. Ignore messages with long lines wrapping in the console. Okay, so the code for quote emitter is the following. Okay, so we have a class quote emitter that extends the event emitter class. This gives us the emit function as well as the on function. So we'll use the emit function over here, and we'll use the on function inside of index.js. Okay, so inside our constructor, the instructions tell us to accept, the constructor accepts a day emitter object. Okay, so we're going to pass in a day emitter object, and in addition, I'm going to pass in the quotes data. Okay, so you can pass in this case, it's just an array of objects. So this quotes is an array of strings, and day emitter is our same day emitter from all the previous examples. Okay, so we're going to take day emitter, and we're going to attach a listener to the new day event. Okay, so when we get a new day, we're going to get a month, day object, just like previously. And then, again, this is going to happen every 2,400 milliseconds, or if we change the time value, it can happen faster. And what we're going to do is we're going to look inside of our quotes array. We're going to choose a random number between 0 and 1, multiply it by quotes.length. And this last bit over here will discard any decimal digits. Or you can just, so this is just essentially a shortcut for math.trunc or math.floor. Okay. But it saves a couple of characters. So it's better for me to sort of show it to you and then explain how it works. And inside of your own code, you might have used something different. Okay, but this is a bit interesting to try out yourself if you want. Okay, so that's going to give us a integer value between 0 and the number of quotes inside of here, the length. And so that's going to be the quote that we choose. So we're going to choose one random quote from inside of here, and then we're going to emit that to whoever's listening for QOTD events. Inside of our index file, we're going to be setting up a listener. Okay, so over here we've set up our day emitter, and over here we've set up our quote emitter, passing in the quotes array, the quotes JSON data, and the day emitter from that we instantiated. Okay, so that's going to give us a quote emitter, and we're listening to the QOTD event. If we get a new QOTD event, then that's going to give us, okay, so if we look back inside of here, we can see that when we do emits, we pass in a quote. So it's going to give us a quote as the inside of the event. And so we're going to take this quote. Okay, so our second parameter for a on function, the first parameter is the event that we're listening to. The second parameter is the callback that we want to execute. But inside of that callback, it's going to always give us back the data corresponding to the second argument over here, which is the quote in this case. So we can extract the quote out, clear the console, move the cursor to the line 1. Okay, again, line 0 is reserved for the date to print out, so line 1 will be our starting location for our quotes. And then we use console.log quote to print it out. Okay, so let's run this. Okay, so on every new date, a new quote will print out. In the next example, we are going to be looking at a stock notification simulation. This third problem has us starting with a stock portfolio similar, with a smaller portfolio. So in the previous examples, we had 9 stocks. In this example, we only have 2 stocks. Okay, and you are tasked with creating 2 files, a price emitter module. Okay, and so this is going to accept a stock emitter object and a target price and direction. Okay, so it's given a stock object, and we know that the stock object emits a new price every day. Okay. It also has a target price that we are interested in the stock at, and a direction, so above or below. So if we look at the data inside of stock alerts.json, also these are our stocks, right? So we have Google and Apple, and their initial price is 1520 and 324. Okay, and we have a second file, stock alerts.json, and this file contains a ticker, the target price. Okay, so the first one is target price 1800, and a direction above. So what this is saying is, if this data is trying to say, I want to be alerted under the condition that the stock Google goes above 1800. Okay, I want some alert to pop up. I also want an alert to pop up if the target price goes below 1300 of the same stock. Okay, and if Apple goes above 350, then I want a message as well. And finally, if it goes below 275, I want a message. Okay, so over here in this sample over here, we can see that the price is on the first 2 lines, and it's changing up and down. And then if it ever goes above the target price, then a message pops up. Okay, and this will happen every day. So if the price on the first day is 1900, then this will fire, this price alert should fire. And then on the next date, it's 2000, it's still above 1800, so it'll continuously print out. So again, that's just because it's a very simple example. And if we wanted to create something more complex, we could, but it'll just add to the complexity of the code. So if there are multiple days where the targets, the emitter should fire, then they'll just fire. Okay, so price emitter emits a price alert whenever the price threshold is passed. The second argument on the emitter should be an object containing the date, ticker, target price, direction, and price. Okay. So let's just do a quick conceptual idea of what we're doing. Okay, so we'll have some stock, let's say Google. Okay, and essentially that price, it'll have a initial price, let's say 1530, and essentially what we're doing is we're setting up multiple sort of trackers. So we might have one at 1800 and above, and one for 1300 and below. And essentially this stock is gonna, because each day it gets a new price, it's gonna move up and down randomly. And essentially if it ever goes above our price alert, okay, if it goes above our price alert, then we'll get a message. Okay, so we'll get a message on this day, and if it continues to stay above on each additional change in the day, it will continue to get messages. If it falls below, we stop getting messages. And if it goes way below to our bottom threshold, then we'll again get messages. Okay, so that is the general gist of what we're trying to do. Okay, because we can't really predict the stock price, it's random. Instead, we'll just track to see what the price is, and if it hits our threshold, we'll output a message. Okay, so the instructions gives you a bit of hints on how to construct the constructor. So the constructor itself, it tells us that we need to build a price emitter element. And because this is going to be emitter, we should extend the event emitter class, because we want the methods on and emit. Okay, so we want to be able to say new price emitter and then have something use that price emitter with a on method. Okay, inside of our index file over here, we have, let's see, right, new price emitter, and then we do a on function over here, but I'll uncomment that in a second. Okay, so because we want to have access to the emit and the on methods, we extend event emitter. This super function pulls all the methods from the event emitter, so we have our emit and on methods. So inside of our class that's going to be doing the emitting, inside of here we want to have the emit function, which we do. Okay, and then on whatever is listening to it, we have the pairing with the on method. Okay, so our constructor over here, again, it says that we should take in a stock emitter object, which is the third parameter over here, a target price, which is the first one, and direction, which is the middle one. Okay, the order doesn't really matter in this case, because we're using a destructuring assignment over here. So it's actually inputted as a single object. But when you, inside of JavaScript, when you insert a single object and you use the name parameters, it's creating new instance variables with those exact same names. So inside of here, in fact, this is bad. This is not yet. So if I do something like new price emitter, okay, I'm gonna pass in some objects with the target price, direction. In fact, the order doesn't even matter when you do it this way. because the only thing that matters is the property name. Okay, so if I say target price is 1, stock is Google, direction is above, okay, then in this case what's going to happen, my constructor is going to take this object and extract out target price, and under the hood it'll create a variable. It'll create a variable target price with me. Okay, so for each of these it'll create a variable. So this is a very nice shorthand. So instead of having to create a bunch of variables, I just take my object and I destructure it. And again, the only key thing that you have to remember is the order no longer matters when you're doing this, but the names must match exactly. So over here, when I use it, where is my constructor? Okay, so over here, I have a new price emitter, which takes in stock alert data, and stock alert data comes from this object. Okay, and this is probably more complex than I want to look at right now. Stock alert, but the data is coming from here anyways. Okay, so just trust me on that for now, and I'll sort of explain it when I get to the index file. But we can see that it's got a ticker, a target price, and a direction. So using that information, we're going to pull out those three values: target price, direction, and stock. Where stock itself is the stock object that was created. Okay, so we're going to use the stock object that was created, attach a new day event to it. Okay, and from our previous examples, we know that's the stock emitter. When it emits, it's going to give us a object that has month, day, day, ticker, name, price, previous change. And again, this is another nice thing. Over here we have 1, 2, 3, 4, 5, 6 pieces of data, and this is way more data than we actually need. So if you were using a more traditional method like comma separated lists, then the order of these variables sort of matters, and you need to put all 6 if you're trying to use something near the end. But if you're using a single object and you're doing the structuring instead, you can use this much more concise syntax where, well, I don't care about the change or the previous or the name of the stock. If you don't care about those particular values, then you just ignore them inside of here. Okay, so this is why I really prefer the structuring assignment. You don't have to have all those. The order doesn't matter. What actually matters is what you name those properties. Okay, so we are pulling out the month, day, day, the ticker, and the price from the stock. Okay, remember this stock is going to emit a new price every day. And so we're going to check that price and see if it's above, if we're tracking if this price emitter is tracking for above. Okay, so remember when we're creating the stock, it's going to give us some value. It might be above or it might be below. Okay, so let's take this as our first example. So if we're building the price emitter for this particular record, so in fact, over here, we're going to have 4 price emitters. Okay, so we're building the price emitter for this very first one. We care about if the price goes above 1800. Okay, so this is going to be above. Target price is going to be 1800. And the stock is going to be the instance of the Google stock. So if the instance of the Google stock goes above 1800, okay, so if the price is above 1800 and the direction I'm tracking is above, then I want a price alert to fire. And then conversely, if I'm looking below, then I want it to be the price to be less than my target price. Okay, so I'm going to remove these default values as they're not actually part of the solution. Okay, So I'm going to send out a price alert. I'm going to send out the current date that the alert happened on, the ticker symbol that triggered the alert, the target price that you were checking for, the direction that you're checking for. So you say something like your target price of 1800 was hit. Your target price of above 1800 was hit. The current price is 1820 or something. And this emit is going to be caught inside my index file by this on method. Okay, so we're gonna go through this block next. Okay, so this is actually very heavy in code, but it's very dense. But essentially, what we want to do is we want to set up multiple stock alerts for each stock that we have. Okay, so over here, in fact, if I comment this out, this is the same code from the original demo. So this will just print out the stock prices. Okay, so this will print out the stock prices every day. So we know that we have two stock objects. We have a stock object for Google, and we have a stock object for Apple. Okay. And what we're going to do is we're going to loop through our stock alert objects. Okay, so we're going to loop through each of these. Okay, we're going to take this, take each stock alert object. Okay, so we have 4 stock alert objects. Okay, so we're going to take each of these stock alert objects and we're going to look up the stock that the ticker is associated with. Okay, so we're going to match it up with this one, this stock object. And then we're going to take that stock object and we're going to create create a new price emitter for that stock alert object. Okay, so we can go through this. Okay, so stock alerts. Okay, stock alerts is going to be, again, this entire array. So this is an array of stock alerts. The map function is going to loop through the results, and it's going to return back a new array. It's going to return back a new array based off of the results of this function. In order to create a new price emitter, we need target price, direction, and stock. We need these 3 pieces of information. But our stock alerts.json only has 2 of them. It has target price and direction. Okay, so we have target price and direction, but we don't have stock. We have the ticker, but the ticker is not that useful to us over here because we can't attach a emitter to the we can't attach a on method to the emitter. So if we pass in the ticker, this code won't work because this is looking for a stock, and the ticker is just a string. It doesn't have a on method. Okay, so what we're going to do is, what this first one does is, this is a spread operator, and so it's going to take my stock alert, which in this case would be this data over here, and this is just shorthand for sort of putting the data inside of here. So it's going to take that object stock alert and use its properties as part of my new object. So essentially over here, I'm trying to create a new object. Okay, I'm trying to create a new object that has the stock property. Okay, because our price emitter requires this structure: target price, direction, and stock. And so this will give us target price and direction. It also gives us ticker, but we're not really going to use that later once we have it. And again, if you supply anything into here, into the object that it doesn't care about, it will just ignore it. Okay, so we have target price and direction from this spread operator. What we still need is the stock object, and this is where it comes from. So the stock object is the stock property is going to tell us to go to the portfolio object. Okay, so that's this over here, which is an array of stocks. Find the stock where the ticker of the stock matches the stock alert ticker. And find is a function that will return the first element in array where the condition is true. Okay, so this will find the stock that matches Google. Okay, and so at that point we'll have 4 things inside of here. Okay, we'll have these 3, ticker, target, price, direction. And again, ticker is going to be ignored because our constructor doesn't use it. And then finally we have the stock. Okay, and that gives us everything we need to create a single price emitter. Okay, so now we can go back to the map function. What the map function does is this, we have an array of stock emitters. Okay, and so it's going to run this function as many times as there are instances of stock alerts. So over here I have 4 stock alerts. It's going to run this function 4 times. Once for Google 1800 above, one for Google 1300 below, one for Apple 350 and above, one for Apple 275 and below. So it's going to run it 4 times in total, and then it's going to take the results of that and return back an array of those objects. So in fact, if I run this, over here, so if I create a temp variable and I use console.table on this temp, okay, let's see. I will also have to disable this so that this doesn't erase all my information. Okay, so this will give us back a table of 4 emitters. Again, ticker, target price, direction, stock. So you can see that we have this inside each of these is an object that has these properties. And this is what we need to create the price emitter. In fact, we have 1 column too many. We don't need this ticker. But again, we designed it using the structuring assignment, which will just ignore this column. And so we'll have target price, direction, and stock, which is of type stock objects. Okay, so that's what this, oops, deleted the wrong one. That's what this first line does. It sort of massages our data into the correct format. Because again, initially we only had these 3 columns, and this was not enough. We needed a stock object. So what do? We took this ticker symbol and we looked it up. We used this find function, okay, which is just a lookup, and we looked inside of this portfolio array. Okay, so we looked inside of here. We used this to create our stocks. Okay, so we use this. We used this line over here to create a bunch of stock objects. Okay, and then we just loop through each of these stocks, and we check to see the one where the ticker matches our ticker from the stock alerts. And so that will give us the stock objects. Okay, so now we have an array of, again, stocks with the price alert and the target price. And so we can start creating price alerts at this point. So over here, we just go through each of the same results. The for each and the map functions are very similar. They both iterate through an array. The only difference is map has a return value and for each doesn't. Okay, so when you do map, you get a array back containing the results of the process, and for each, there's no return value. Okay, so we're looping through, right? This is a really good example. In fact, over here, we're looping through each of these. Okay, so this is the return value that we had from temporary. So we're looping through each of these. So we'll start off with the Google 1800 above and the stock object for Google. And then for each one of these, I'm going to create a new price emitter based off of the price emitter data. And then once it's created, I'm going to immediately attach a price alert function that will trigger this price alert function, price alert listener on this event. So it's going to listen for this event over here, line 8, inside of price emitter. And this event is going to give us all of this data over here. It's going to give us the month, day data, the ticker, the target price, the direction, and the price. And we're going to pass that. We're going to pass the results into a function price alert, where we have, again, another destructuring assignment for the data that's passed back. So in fact, over here, I don't think I need this spec. I don't think it's necessary. Okay, so this is going to take the arguments and destructure them into the components that were supplied. And again, because we're doing this object destructuring, the names matter. And then we just, again, print out the information from here. Okay, so price alert will be ticker, price, direction, target price, and on date. And then for each one, we'll increase the line. And that's about it, really. Over here, we move the line down every time we need to print a new date, but we move it back afterwards. So let's run this. I disabled the day emitter. So because there was no day emitter, then none of this, of course, works. So I need to re-enable the day emitter. And then we get our stocks flowing. Okay, so once the stock falls above or below one of the threshold values, so our threshold values are 275 and 1800. Okay, so they haven't went above or below yet, but if you just wait a little bit, there you go. Okay, so this has gone above 350 on a specified date, and if it continues to stay above that price, then the notifications will continue to output. Okay, so let's see. Right, so let's try again and see if we can get anything for the belows to trigger. Okay, cool. So this one has now gone below 1300, and again, we get a price alert. The next question is the bad word detection, which is actually just a substring detection method. So the question has us writing a program to track how many bad words a user has used in a fictional chat application. The list of bad words is just initially a bunch of Java keywords, but you can modify this list as you want. Okay, this is all stored inside of a JSON file, badwords.json, and it's just an array of strings. Okay, so this is going to be passed into a module, bad words emitter. Okay, so our bad words emitter is going to need a constructor that accepts a list, an array of bad words, and a readline interface. And this is going to be very similar to the third the example where we were accepting user inputs. So we're going to listen for a line event. And for each word found that matches something inside of bad words, inside of that array of flag strings, emit a signal bad word. Okay, so we're emitting our own custom signal. Each bad word signal does not have any additional data. Okay, so this one's a bit interesting. In our previous examples, we supplied some data. In this case, we're just emitting a signal without any extra data. So in fact, if you look at our emit function over here, we can see that it only emits a signal. There is no additional data. And what's going to happen is what we're going to do inside of our index files, we're just going to count the number of bad words that they've said. Okay, and if we have a string like that uses multiple bad words, so because we're not detecting on every character they type in, we're detecting on every new line. Okay, so it's checking the line event. And over here we are checking the line event. So it's very possible that they might use 2, 3, 4, etc., multiple bad words. And then in that case, we're going to for each bad word that they said, then we're going to emit a separate signal. Okay, so they said it 4 times, 4 bad words, then we want to emit 4 times. Okay, so just some clarifications. Matches should be case insensitive. So for that, we can just use a lowercase function. And index.js listens for bad word events and will keep a counter on top of the program. The counter should appear after the user has said their first bad word. Okay, so over here we have a counter representing how many bad words they said. And over here we have 2, which adds up to the previous one, and we get 3. Okay, and then over here, I think it uses 3 bad words, and it should jump to 6. Okay, so let's go into the code. So again, we had a constructor that takes in a array of bad words and a readline interface. That's just defined over here. Okay, because this is a emitter class, it's going to extend the event emitter. If we want to have the ability to use the on method and the emit method. Okay, so over here we use the emit method. We want to have access to this, and then inside of index.js, after we've instantiated an instance of bad word emitter, we use a on method over here. Okay. So it's not the same as this one. This one's the readline interface, which is already an event emitter. Okay, so we don't, when we say extends over here, when I say it gives you the access to emit and extend, I'm not talking about this one. I'm talking about this one, because it's using the this keyword, so it's referring to bad word emitter. And this one, because we instantiate an instance of bad word emitter. So when I say this one dot on, it's referring to the bad word emitter's event emitter class. So the super function gives us access to the on and the emit methods. And then over here, we're just doing a bit of preprocessing because the code says that it cares on matches should be case insensitive. So we're just going to loop through all the bad words. We're going to apply a function that takes each individual bad word, applies the to lowercase function to it, which will move it to a lowercase version. And then because this is a map function, we get an array back of all the resulting data we stored into the original array. So we erase the previous contents with a new one that has a lowercase version of all the original texts. Okay, so that should take care of our case sensitivity. When we get a new message on, we're going to lowercase that, and then it should be case insensitive. So we attach a listener to the readline event. Okay, and again, this is a interface method which extends the event emitter. You can look back at the original lectures to see more in detail about the readline. Okay, so this one has several built-in methods, including a event for when the user hits a return key on their keyboard. That's the one that we'll mainly be using. I believe readline has like 6 events. And so this is the one that we care about. When they hit a new line, we're going to get that message that so when this event fires, this function over here, in fact, I'm missing one, this function will execute, this callback will execute. And this callback, it's applied a piece of data. Because this is a built-in function, it's applied a piece of data message being whatever the person typed in. Okay, so we're going to apply a lowercase function to this. And then essentially this block of code over here is counting how many bad words that they said. And again, over here we, actually let's be more specific. It's storing all the bad words that they said into the uSet array. Okay, so every bad word that they said, every instance of the bad word, we're going to store it inside of here. Okay, so over here we have our list of bad words, and we have 6 of them. So it's going to go through this list of 6 words for each bad word. Okay, for each bad word that exists, we're going to take the message, and we're going to, this split function allows you to sort of tokenize a string on a keyword. And what we're going to do is we're going to tokenize on the bad word. So if we had something like okay, so let's assume that this is our string over here. So what the split function does is it returns back an array. And what it's going to do is it's going to tokenize. So essentially it's going to go through our string, and then every time it sees the first instance of the word that we're splitting upon, in this case we're going to be using the word Java, it's going to break up our string into multiple strings. So in fact, if it doesn't find anything, the return back value is just the original string inside of an array. But over here we can see that it's got 1 copy of Java. In fact, it's got 3 copies of Java. So as soon as it sees the first instance of Java, it's going to break our string up in half. And so our index of our first splitted string will actually not contain the bad word, but the one after it will be the first instance. And then over here I see a second instance. So again, I'm going to split my string. Over here I have a third instance. And that's it for the word Java. Okay, so in fact, if I have a particular word appearing n times, then when I split the string, I'm going to have n plus 1. We're going to have n plus 1 elements inside of this array. So if I want to count the number of times that I've seen Java, that's going to be whatever the length of this splitted string is minus 1. Okay, and that's going to be the number of times that I saw this particular bad word. There's other bad words like JVM, but we'll count those when we loop back to the next bad word. So first we're doing Java, then we'll do JRE, then JVM, and eventually we'll get to all the words. Okay, so for each one, we're going to create an array with count. Okay, so we're going to create an array with a bunch of empty slots, and we're going to fill it with the bad word. And then we're going to concat that with the empty array you said. So essentially we're going to go through each of the bad words. We're going to count the number of times that they appear inside the string. And then we're going to sort of put that into an array you said. So at the end of this, it's going to have an array of a bunch of bad words. So in this case, it would be Java, Java, Java. And then the last word was JVM. Again, that's just because the JVM occurs after Java. Then for each of these words, we're going to emit a bad word event. And again, in this case, we might have been doing a bit too much work because we don't actually care about the specific values of this. But that's something that we can sort of add on later if we actually want to know more specifically what did they say instead of just counting it. Okay, so let's go to the index file. So inside of the index file, we create an instance of a bad word emitter, and we're passing in as its parameters the array of bad words as well as the readline interface. Okay, so now every time the readline fires, our bad word emitter will emit a signal. So we listen to the bad words on bad word event. And when this happens, we're going to increase the count by 1. And then we do a bit of string manipulation. Over here, we move the cursor to the very beginning of the line. We erase the line. And then we print out, so we erase the current content of the line, which initially is welcome to this chat. And then we only when we've detected a bad word will we sort of send this message. So they never say a bad word. They'll never see this event happen. But we're going to erase the original content and just replace it with almost the same string, but we have this bad word count over here. And bad word count is initially 0, and each time a bad word is fired, it increases by 1. And then we move the cursor back to where they were previously, +1. Over here we have a function shell prompt, and that's just what's drawing this caret symbol over here. So every time we receive a online event, we call shell prompt, which will print out this caret symbol and also increase the line by 1. Okay, and that allows us to move back to the current line if the person pushes enter or a bad word occurs. And that's because we need to move our cursor. We need to move our cursor back to line 0 if there's ever a bad word and update this value. Okay, because if they type in a bad word, the counter appears on the side. Okay, so over here you can see that value, bad word count, has to be updated each time a bad word event fires. So we have to move our cursor back to line 0, and then we need to have some way to move back to this line +1. Okay, and that's what this is doing over here. Okay, so let's run this. Okay. If I use it multiple times, it should continue counting. Okay, so this looks fine. The last problem is the Morse decoder problem. Morse code is a method used in telecommunications to encode text as standard sequences of 2 different signals, a dot for a short signal and a dash for a long signal. In our applications, we're going to add a third signal, break, to denote the end of a character. And this is traditionally done by having a short pause. So over here we have a file morse code.json inside our data, which are just pairs of characters and their corresponding Morse code. Okay, so we're going to use this to sort of encode and decode messages. So we're going to create a file index.js that decodes the secret message emitted by Morse emitter encrypted.js. Okay, so this is a interesting file. And the reason it's interesting is in all our previous cases, when we wrote a emitter class, we were able to sort of look inside the contents of that file. But this file I've purposely obfuscated. It's actually not encrypted, it's obfuscated. The code is just made to be really hard to undo. So in fact, if we look at this file, we can see that it's basically impossible to read. It does work, it's just designed to be unreadable unless you pass it through some programs first to sort of unhide the message. Okay. So this file, we can treat it as if it's encrypted. Okay, but it's actually obfuscated. Okay, so we can still run this file. But we need to write a file index.js. Okay, so in fact, we can hide that for now. And so we're going to do this by just using the instructions that were supplied. So we're going to, so we can sort of treat it like readline. We specifically don't need to know for the readline interface, we specifically don't need to know how the internals of the readline interface work. All we have to do is listen to on methods. And so we're going to do the same thing over here. We don't need to know how the internals of this monstrosity work. Okay, we just assume that it works, and then we assume that it's got an on method. Okay, and it's going to tell us about the events that it's going to signal. Okay, so listen for events dot dash and break emitted by Morse emitter. So okay, so we're going to instantiate a instance of Morse emitter. Okay, so over here we require that module. Okay, this is the same sort of way that we've done for all the demos. We're going to bring over our translation code, our Morse.json file. Okay, so we're going to import this file over as well. This is just to be an array of a bunch of objects containing a char and the corresponding code. And over here, our first function translates from Morse to characters. And all it's going to do is it's going to take the data. Okay, that's going to be representing the Morse data. Okay, and it's going to use Morse.find. So it's going to go through here, goes through each instance of here, and it's going to look for, let's see, CV. What did I call this CV? So current value dot code. So does this, so it's going to loop through these objects. It's going to say, does this code match the code that was supplied in? Okay, so does this code match the Morse code that was supplied in? If so, return back the object's char parameter. So if it was dash dot dash, okay, then return back the character K. Okay, so that's what it's just a conversion function. Over here, we instantiate an instance of our Morse emitter. So that's going to create the Morse emitter. And then over here, we have a start method. Okay, so Morse begins to start sending signals when the start method fires. Okay, similar to how our day emitter starts firing signals when we call the start method. Okay, so this is the sort of new code that we added on. So essentially what we're going to do is we're going to, every time we hear it, we're going to listen for characters. So we're going to listen for a dot and a dash signal. Okay, so these are two signals that we're listening for. So we're listening for events dot, dash, and break. So if for each signal that emits, we're going to store it into a string data. Okay, this is going to be our, in fact, this can be our character in Morse, or Morse character. Okay, this is going to be our Morse representation of character. Every time we hear a dot, we're going to add a dot to it. Every time we hear a dash, we're going to add a dash to it. Okay, and when we hear a break again signals that the end of a character has appeared. Okay, when a break event is heard, convert Morse character into an ASCII character and print it using process.std out. Okay, so again, the break denotes the end of a character. So when we hear a break event, we're gonna trigger a function that takes our Morse character. Okay, take this Morse character, convert it to a letter, and then write that letter. In fact, we can make this a const because we don't ever change it again. And then we erase Morse character. Okay, so that's so that the next signal can execute. Okay, and so if we run this, okay, you can see that the Morse emitter encrypted will begin to emit signals out. Okay, and each time it emits a signal, it's going to get caught by the one of the on methods. Okay, so over here I'm showing that you can have multiple on methods. Over here we have 3 different events that are simultaneously firing. Every time a dot event fires, this function executes. Every time a dash event fires, this one executes. And every time a break event fires, this one executes. And then the second part of this question, the second step, has us now building our drop-in replacement. So we are writing our own Morse emitter. So instead of using Morse emitter encrypted, we want to use Morse emitter. We want to write our own. Okay. So essentially, we want to replicate the functionality of Morse emitter encrypted, but we can't look at this code. Okay, so all we can do is understand how it works. Okay, so we know that it's emitting 3 signals because we have 3 listeners over here. So it's going to be emitting a dot, a dash, and a break. Okay, so when we create a Morse emitter, okay, when we create a new Morse emitter, what are we applying? We're giving it almost nothing. Okay, so it doesn't need any additional data to work. And it looks like inside of our code, let's see. So let's read the question. So the previous step must be complete. First, create a file Morse emitter.js that acts as a replacement for Morse emitter encrypted.js. Your version will be improved because it won't have a built-in delay like mine's. Okay, so mine's has this built-in delay when you, the one I wanted. Right. So yours should be much faster than mine's because mine's has this built-in delay inside of it. So the code starts with importing the event emitter class. We pull in the Morse code JSON file. And we have a function string to Morse, which does the reverse of Morse to string. There's a slight additional change. So when we are converting from a string to a Morse, we need to later signal that a end of character has been reached. So as an example, if we have, let's say, we may have a character dot dash. Okay, so character E is just a dot, and character A is dot dash. So there's no real way for whether if I see something like dot dot dash, okay, I need to be able to see, is this a E followed by an A, or is it some other symbol inside of here? Okay, because dot dot dash is a U also. Okay, so we need some way to break up our characters. So we introduce a third symbol. The slash represents a break. So it represents the end of character, which we will signal inside of our emit with a break. Okay, so that's what we did over here when we listened for the break event. And so the break just represents the end of the character. So we're going to take our regular string. So in fact, it should just be string. Okay, this is just going to be our regular string. And we're going to split it again on each character. So if we have a string A, B, C, D, okay, it's going to be an array of string A, followed by string B, followed by string C, followed by string D. Okay. And then we're going to map each letter. Okay, so we're going to take each letter and then do something to it. We're going to do morse.find again. Okay, so that's going to look for the associated Morse code. Okay, so it's going to find the Morse code that is associated with a matching character. So if our character that we're currently looking through, so essentially we're looping through each of these character columns, and then as soon as we find character A, we're going to return back this object, and then from that object we're going to extract out just the code. Okay, so that's going to give us something that looks like, let's pull out ABCD. That's going to give us something that looks like this with just the code. So it's only the code that we were pulling out. So it should look something like this. This is an array of the Morse codes. And then we're going to apply the join function. Okay, so the join function, will combine these strings using a joining character. In this case, it's going to be a slash. So this is replaced with a slash. This is replaced with a slash. And this is replaced with a slash. Okay. And then finally, we have one last slash at the end that I'm attaching on. Okay, that's what this last plus slash is for. And that's just to signal that the last character is also ended. Okay, and that's going to help our emitter because it's only going to check for this character before sending out the emits. That's what this else statement down here is. Okay, so we have this over here. This is our sort of working string. So this gets passed into, this gets saved to converted. So our converted would have something, in fact, this double slash is not ideal. Okay, so converted would look something like this. Okay, so when we run our constructor, we take our secret message, we call super to instantiate, to give us access to the emit, to give Morse emitter access to the emit and the on methods. We take the whatever string was typed in, we apply to upper to it. That's just because our Morse code file only has uppercase letters. Okay, so if we're going to match anything, we need to convert it to uppercase. And then we're going to take our string, apply string to Morse, take our message, apply string to Morse to it. That's going to be converted. There you go. So this is what the current value is if we use ABCD. And because I want to use this inside of the start function, okay, I can't just save it to this variable converted. I need to save it to a variable local to the instance. So I need to attach it to this object. So in fact, I can go like this to just ignore the variable converted. That'll save me a little bit. So I'm going to save the converted Morse message into variable Morse data. And then whenever I decide to start the emitting process, then I'm going to loop through this.morse data. Okay, so I'm going to loop through this.morse data. This is just your standard loop, starting from 0 to length. Again, this is what the string looks like. So it's going through character by character of this string. And then if that character matches a dot, so I'm going to emit a dot signal. If it's a dash, I'm going to emit a dash signal. And if it's any other character, I'm going to emit a break signal. Okay, and the combination of that should send the Morse code to my index.js, where it will get decoded because we've already written this previously. All right, so all we have left is to test this code with a new secret message. So we can instantiate our Morse emitter with hello CS355. So I believe you can have spaces inside of here, but it'll truncate them. And that's just a limitation because I did not assign a code to the space character inside of Morse. So I assigned the code empty string. So it's probably better for me to just not have it. We'll just leave it as is. It's still readable. Okay, so you can see that it'll print out hello CS355, and because there's no set timeout or anything inside of here, it just emits everything almost immediately. And the delay that I created was just intentionally so that that you didn't know when the messages could come. Okay, so that's the solution to all 5 problems. Do take some time to sort of review the code and how it works. And definitely try the problems out yourselves if you could not get them solved.